Yeah, everyone, we're here, just kind of catching up, waiting for this. So, yeah. Yeah, let's give it 2 minutes. Hey, um, welcome back, everyone. And I think we can start. Um, I don't know.
Yeah, let's get started. More people will join us.
So, welcome back once again. And it's time to fresh and just refresh yourself here. Hey, yeah, I think I slept off. Yeah, I think that was good. I needed. So, where did we stop? We stopped at evaluation. Just to recap, where did we come from? I'll keep repeating so hopefully you get something stuck and you just remember it. So came from what is machine learning? We came from machine learning, a subset of artificial intelligence, and having built that understanding, we went further to say machine learning task is can either be a supervised task or an unsupervised task. And we dwelt a little bit on the supervised task where we highlighted that really an attempt to make prediction of out of label data by the use of machine learning algorithms. You must say this task can either be a regression task or a classification task. And we went for that to highlight that between both, among both groups, regression and classification, there are different models that serves the purpose. There's linear regression for continuous tasks, for regression tasks. There's logistic regression for classification tasks. A tree-based model, like there are several tree-based model that serves both purpose, decision tree, random forest, gradient boosting, XGBoost. We just give a high level overview of those different types of model. Importantly, we pointed out that each model has its own hyperparameters and they are central to the outcome or the predictive power of the model that you develop. So what we've done, we went further to look at what's the machine learning pipeline itself. We went from data collection and exploration to cleaning and pre-processing to feature engineering to model training and validation to model evaluation and selection. Here we are. So we're looking using this UCI data on diabetes prediction, and we're trying to build, when you have the time, with the maths, the little maths here. But essentially, this is what we're trying to predict. That someone who built out a model, and the prediction is based on someone's characteristics, are they likely gonna do they have an increased risk for diabetes or do they have a decreased risk for diabetes? And we built a model out of that. We standardize our data by using standard scalar. We run our model with a couple of default hyperparameters. C one max iteration of 1,000, setting a random state for it to. And we fit our model. And here are the most important features that our model predicted, right? So after that, we looked at a couple of evaluation metrics, like because you're not just building, you're saying if what I've done is okay, tell me By how much is it okay? All right. By how much is my model good? So how do I be able to tell someone that, okay, this is good. This is a good model you can use it. So this is what shows me that I looked at classification, accuracy, precision, recall, F1. These are things you can look up. How precise is the model? If the models, how exact is the model? And you're looking at exact, is he able to classify one as one, zero as zero? You know, recall, completeness, all ones are classified as ones, all zeros are classified as zero. Now, to be able to show you that the model is doing a poor job, it's only able to classify 50 cases as having an increased risk of diabetes. Meanwhile, we have more than 50 cases. So there's a huge error, there's a huge misclassification error. So it's something you want to do. So if the percentage, yeah, here's something, here's a check, right? The accuracy is 69%, right? So it means it's a misclassification error of around 31. 31% is huge. It's huge. And the precision is 57. So there's a misclassification error of around 43, which is good, which is poor actually. Yes, 50-50. The exactness, the completeness of the model is 50-50, is poor. So that's how I'm trying to think about each of the metrics. So if you look at the overall classification report here, it shows that it's actually misclassifying at least, because you want it to get this, you don't want to have false positives, which is what it's doing here. False negative rather, which is what it's doing here, because this number is low. Right, it's the precision is around 57. It's not precise. It's not exact. Percentage of correct, exactness of the model. So 1 is 1, 0 is 0. It's saying 75% of the time 0 is 0, and 57% of the time 1 is 1. It's poor. So it should considerably be close to each other. If this is 75%, this is 75%, I'll take it, right? Okay, I hope that makes sense. So, and that shows in the confusion matrix. You can dive further and try to look at how each actual prediction stacks against each other. In what was the prediction and what was the actual indicator? What was the actual outcome and what was the actual prediction? To be able to verify if our claim is true. So if it's predicting a 1, was the actual prediction indicator or the actual outcome, was it 1? So you can take that a step further and look at again if you want. So this was model interpretation. Well, this is old now. Not sure if it's still gonna produce 80%. Yeah, it's 81%. Accuracy 75 to 80, balance precision. F1 score is good, but I would ideally want my precision and recall to also be higher. So if my F1 score is high, then yeah, it's okay, I'll take it. But key insights, top diabetes risk factors, glucose level, BMI, and age. Is that what we had? Um, we have glucose, BMI, pregnancy. So there's a change from the last time we ran this model to now. So glucose, BMI, and pregnancies, that's what um it gave to us. So what we could actually do is to look at from our research, right? From one way to validate the claims of your model is to do a research. Is this consistent with what's in the world, like real world scenario? What your model predicted, is it consistent with what's observed in outside? That's one way to tell if your model is doing a good job, right? Then you kind of do a check around the metrics that you use in evaluating the model. So this curve is called the ROC curve. It tries to tell you by how much the model is able to discriminate between the positive and the negative class, between 1 and 0, or in our case, between the probability of increased risks of diabetes and not. The curve here tells us that the model is actually doing a good job. But my concern is there's a bit of up and down and down and up and up and down and down and up. Like, so kind of like a survival curve, then just went straight up. Ideally, I would like love this to be a bit smoother. That's my indicator that the model is struggling. Though it gave me 8%, but it's struggling a bit more. One way to remedy that is, I think I've written this down. Class imbalance. 35% are diabetic, 65% are non-diabetic. You can get a bit closer, maybe 60, 40, 55, 45. Get it a bit more close. And like I said, for simple hypothetical study or just trying to validate your hypothesis, building a simple model is actually always right step to take rather than jumping head first into complex modeling. You want No, we just started here. I don't know if you joined us earlier, but we're just doing a recap of what we've already done. So building a simple model is the first step. Try to like weight your data. What other information do you have? So modeling is usually not linear, say. It's not linear. It's not like you build the model, it's okay, and that's it, you're good to go. So there are different edge cases you have to take. In our case, right? I don't think, okay, yeah, we did test, yeah, test. So if I were to take a different model and check, will I still have the same, or I take a different data and check, will I still have the same results? That's always important. So, like I said, it's not linear. You want to be sure that it's able to handle different edge cases. So clearly our model is able to handle non-diabetic patients here, as we'll see here. It's able to predict this class more. There are a couple of factors that could be responsible. High class imbalance is one of them. So by high class imbalance, I mean one class has more, it has a higher representation than the other class. So there are more zeros than ones. It can result in class imbalance. There are approaches to remedying class imbalance. You can oversample, you can undersample the minority class, or you can oversample the minority class or undersample the majority class. Those are approach to handling class imbalance when you come across them. Uh, let's do a recap. That'll be a long shot. I don't want you guys to get bored. I want you guys to take it as quick as we deliver it and try to run with it, right? So that's why I'm focusing on ensuring I try to make it as simple as possible for you. So I'll pause here. Is there anyone with any question as you go about your the breaks we have? Did you have like thoughts that you like to share on what we're doing? Because next I think we'll move to deep learning. Um, an interesting concept, deep learning. So any thoughts, any questions, any concerns? Your notebook running? Oh, okay. Let's reshare the link to the notebook. Well, I'm going to remove you guys. Then I'm going to share the link. So anyone with any question? So I pointed out something early. They say there's a place you put your random seed, and the reason for using a random seed is to enhance replication. So if I package this model into a pico file or into an endpoint and I share it, someone who runs it is going to get exactly the same result because of this random seed. Very important when you're developing a model. So, um, all right. AI has become advanced. Let me try something. It's always good to, yeah, let's know about. You can chat it. It doesn't have, this would, Databricks, um, platform that I use. I wanted to try some. It's, unmute and tell us what the problem is. It's not, I don't think it's, good use of your time if you attend and you didn't get anything out of it. So please, if you have a concern,
Okay, can you hear me? Can you hear me, sir?
yes, pay.
Okay, during the last session before we went for break, I was part of those people that were not seeing your screen. So, and I'm new to this aspect of machine learning. So I was not able to see what you were doing. So coming back now, I'm a bit confused, and I would really love to follow. I don't know if it's possible for you to recap. That's an appeal anyway.
Yeah, I hear you. So what we've done, like I hope it helps everyone as well. What we've done essentially is take the lessons we've learned from our slides about supervised machine learning. If you recall, excuse me, we did mention that there are two tasks that you can implement in supervised machine learning. One is the linear regression, one is the regression problem. The other one is the classification problem. The regression problems requires the use of algorithms such as machine learning algorithms such as linear regression, while the classification problems, which we predict categories, uses logistic regression, right? So what we've done next is to look at, you saw the slide on machine learning pipeline, right? This pipeline, let me share that screen. So what we've tried to do is to look at this pipeline. To look at this pipeline and try to follow. Actually, I got this from professor in a class I started. So I've always used it as a guide in whatever I'm doing. So we looked at the process to building a machine learning model. The first step is you collect data, you do a bit of data exploration, right? We got this data from the UCI repository. There are other data sets that you can use, right? That you can play with. I think what I did the last time was doing this. Since I'm recapping, let me do this with help. I really want you to get the best out of this. Learning how each stage works and ties together is a great way to start. So this is the pipeline. The slide here we have is the pipeline. We collect the samples for training and we identify the data, we compute histogram, we do data checks, data sanity checks. What's the number of rows? What's the shape of the data? Is the columns even labeled correct? Because in making predictions, we want to know what column is what. We looked at the data. Our first step was what's the shape of the data. After loading the data, what's the shape of the data? We did a few linear relationships. Glucose and blood pressure and glucose were just right there in the middle. We see some spikes and we see some outliers by the side. Just all this was trying to understand the data. Right? You can do much more than this. So the next step was we looked at the data itself, like taking a little dive into it. What's the number of missing? What's the number of zeros? What's the number of nulls? That is the second step in the machine learning pipeline, data cleaning and pre-processing. When we looked at all those from data collection and exploration, we saw that there were anomalies. The next step was to rectify those anomalies, nulls, zeros, missing, labels that needs to be encoded, values that needs to be scaled. So those steps is done in the data cleaning and pre-processing, or you combine them together, feature engineering, right? Okay, the data is sparse. Like when we talk about sparse data set, right? The data is sparse means there are multiple columns, multiple features, and few rows. No, multiple features rather. We refer to them as high dimensional when there's more columns than rows, right? But we stick with sparse, maybe there are more columns. So you want to reduce the number of dimensions because some features can naturally coexist with the other feature. So You reduce the number of dimensions. That's one way in data cleaning and preprocessing. Recall I mentioned both these two steps can actually be together. Feature engineering, data cleaning, and preprocessing, they're actually together. So that's what we did. We look at number of zeros before cleaning, right? Glucose had somebody is playing with this. Glucose had 5 zeros, blood pressure had 35, skin thickness 227, right? So there are so many zeros in our data, and we needed to clean them. We don't, because the model might be seeing the zero as an input. Meanwhile, the zero is missing. I think from the UCI dataset, diabetes dataset. Don't know, diabetes. One is the one we're currently using, but I think as missing, no, this is different. But I think from the data, I think zero meant missing. Zero meant missing, I think. It's still different. They probably like updated the data set and they have more newer data set, right? But I think in our case, zero meant missing. So we needed to impute or transform. You heard this word, imputation or transformation, to deal with the zeros. So our model doesn't see the zero as an input, meanwhile, it's a missing feature. That's what led us to transforming from number of missing to zero. So we looked at that, went for that to just have like a summary statistics of our data. First thing we want to ensure is that the number of rows are all the same, 768. And we looked at the individual columns. The mean is within range. The minimum is 0, the maximum pregnancies. It's possible for someone to have had 0 pregnancy. I've never been pregnant. And it's for somebody to have been pregnant 17 times. I have some comments about that, but it's fine. Grade is 3. Standard deviation is 3, which is pretty close. 35% tag is 1, 75% of the time. Most of the respondents have been pregnant 6 times, which is great. Yeah, it's a good number. So look at all those details and see they're close. Nothing is really an outlier. A blood pressure of 122 is kind of high, but it's within range. So we looked at this, all what we're doing is completeness. After we've done our transformation, we're still checking for completeness. I made a statement that yeah, zero mean non-diabetic. I made a statement that good data, bad model is still a bad predict, is still a bad outcome. Sorry, yeah, it's still a bad outcome. Bad data, good model is still a bad outcome. All right. So good data, good model, that is the place you want to be. I think, Robert, your hand is up. You have a question?
Yes. Yeah, thank you so much for good presentation and informative. I have one question. I know that these are different data. First, maybe we have the different data. Do we use the same prompt that you have here, or we have to generate our own prompt? Because I can see how you've done them, and then they're coming with the count, mean, standard deviation, and minimum. Should we come up with our own prompt, or these are yours?
So what we're doing in this training is to actually to fish but you can teach you how to catch catfish, but you can also catch a shark if you practice very well. I don't know if the analogy works. So, but yeah, this is a good place to start, but you can actually go a bit further. You see, I was mentioning like I use summary statistics in my own case, right? In what I would have done differently is I would look at the histogram of each of these attributes. That's what I would do. I'll look at each of their history. I would just run the for loop across all of them and generate a histogram for each of them, right? Then I will look at the distribution. Is anyone skewing to the left or to the right? Or is it normally distributed? That's one. If there is a wild distribution, I think we did. I started looking at it briefly, like this guy, right? I discovered that it's skewed to the right. And in my mind, I'm thinking there are probably like two groups here. What if I categorize this? I bin it into 0 to 1 and 1 and above, right? That is an element of feature engineering, right? I'm engineering the features as how best I understand it from research, from the data that I'm seeing, right? If I look at pregnancies, I look at pregnancies, which is like counts. I So you see, zero is dominating. So like I mentioned last time, there's probably two groups. There's probably two groups. If I use count plot, sorry about that. If I use count plot to visualization, if I use yeah. So there's probably like 2 to 3 groups, or I'll say 3 groups here. So I could try something. I could bin it. I could convert it to categories, group it into 1, 2, and 3 groups. So those are all feature engineering. So it's not like one size fits all. Different case studies might require different approach, but it's always the same. You're treating a feature differently, you're taking the average, you're imputing mean, you're trying to decile it, you're trying to bin it, you just everything you probably learned in statistics class, you kind of apply it to data in some way. All right. So I hope I was able to shed some light to your concern. These are all don't throw yourself up. We are just looking at a sigmoid function. We use it to predict probability. Don't really need access to this sheet. I think someone is trying to access this. Don't bother yourself about this sheet. I was really just trying to see what tools, just curious what tools is available. When I came across it, it gave me suggestions. I was just trying to look at it. So if we try to predict a new class, I'll say for a patient with X, pregnancies 2, glucose 1, BMI 30, based on the coefficients that are model predicted, right? How do we see a model coefficient? This model does actually this. Print out this, right? I print out this. tell my model I can use it to make a prediction. I can use it to make sure that someone with a BMI glucose level of this, blood pressure of 180 or whatever it is, the person is either going to be diabetic or non-diabetic. That's actually the goal. So what it generates is kind of like an odds ratio. So you have a range, you have a threshold. So it's standard. If it's above 0.5, then there's an increased likelihood. If it's below 0.5, there's a decreased likelihood. So that's just that without going into small details. So any question back to classification metrics? Here's how we validate our reports. Clearly, our model does a better job at predicting the non-diabetic class as compared to the diabetic class. And one of the reasons for that is class imbalance. So there's more non-diabetic class than the class. One remedy is to handling this is either we oversample this class to make it equal, then we introduce noise to our model, or we undersample class to make it equal to the diabetic class, then we are losing data. Second approach is to explore the models as well to see if they will perform better than the ones we currently build. We will build on top of it. All right, any question? I think that's a good place to hang the net, and so let's go into deep learning. Anyone has any concern, question? One more. I think I'm getting this, but something is not settling in well. Kind of concern. No, to go. Okay, I think everyone is cool. Meanwhile, you can also unmute and ask your question. No question is a bad question here. So, let's jump into deep learning. Coda, what we're really doing in this class is give you a bit of basics to go look for, go explore your curiosity a little bit. So why deep learning? What is deep learning? The way we started. So who understands what is deep learning? And they want to share, like, what's your understanding of deep learning? Have you had it before? Have you come across it before? Have you seen before? Is this your first time? Anyone wants to take a stab at that? Like, just keep going. Okay. So deep learning, oh, yeah, please go ahead. I see someone's hands raised up.
Can you hear me?
Yes, we can hear you.
Okay. So my understanding of deep learning, just like AI is a subsection of machine learning, deep learning is a subsection of machine learning. So just like the name implies, it's deeper, and it can be used to solve more complex problems. And I think another subsection of it is the neural networks.
Right. Right. I think you actually did a home run there. That's good. Yeah. Yeah. Deep learning is a subsection of AI. Machine learning. It just keeps breaking down, right? You have AI, you have machine learning, you have neural nets, then you have deep learning. Just comes down that way, filters down. So if I can help, say by way of comparison, machine learning and deep learning, right? So machine learning uses algorithms such as what do you call it? Random forest, decision trees, and linear regression, right? Deep learning uses neural networks. So what are neural networks? Interconnected layers of neurons. Take, for example, the human nervous system, right? Yeah, the spinal cord is connected to the brain is connected to the eyes, and the eyes, the brains, the brain itself has so many neurons functioning for us to be able to make decisions, for us to be able to retain new information and all that, right? So deep learning functions by connecting different layers of neurons together, right? Different layers of neurons. While machine learning can learn from maybe a small subset of data, I don't know if there's a limit to deep learning because it's an interconnected neurons of layers. It's kind of like it requires vast amount of data, right? It requires vast amount of data. So for classical tasks, I think one of the projects I built for my postgrad was to compare deep learning versus ensemble learning. So my ensemble learning was collection of decision trees. So I stack layers of layers of layers of decision trees, just like neural networks, Then I built an NLP model out of in deep learning to perform the same task and to actually see which model, if stacking more machine learning model, is going to perform considerably close to a deep learning model. But it didn't actually. Deep learning was still better. Well, take home is this: deep learning it takes the goalpost further for more advanced tasks, especially for image classification, for audio classification, for text classification, right? Deep learning is better because they are complex tasks. So hence they require complex model. Speech classification. Actually, one of the project I wanted to work on initially was to be able to classify bird sound, a particular species of bird. But there was no compute power. Even with the laptop PC I was using, I thought it was great. I looked at it, I looked at the computational requirements, it was just going to crash it. So I had to settle for something a bit less. So when there is requires more compute, actually your GPTs and your co-pilots are all deep learning models. Actually, they are deep learning models, right? Huge amount of deep learning models, multiple layers of hidden neuron layers. Only God knows how many layers of how many neurons and layers was used to develop them. But it's huge, huge. They're all deep learning models. So another comparison between machine learning and deep learning. Yeah, I've reported that it requires heavy computational power. So deep learning requires the network kind of figures out what to do. That's the best part to it. While in classical machine learning, you get to do a lot of feature engineering. If you feed it into deep learning network model, it's going to figure out what to do. Now, how do you build deep learning model? The deep learning model is basically a collection of neurons, and it's structured as you have the input layer, you have the hidden layer, and you have the output layer. So here is our input, the features that are feed into it. What goes into the model that generates the outputs are the hidden layer, and there can be stacks and stacks of them. As you can see here, you see there's both a forward and a backward movement. Okay, someone is scribbling. So there's both a forward and a backward movement. So it's called back propagation. There's a kind of like an ordinary differential equation that goes in. We tried to solve it once, and yeah, that didn't end very well. So you can stack multiple layers depending on how complex you want your model to be, right? Depending on how complex you want your model to be, stack different layers. So basically the structure is you have an input layer, you have a hidden layer, and you have the output layer, the prediction. So let's say if we're to do the same diabetes prediction. So all our inputs, what will go into the input layer will be pregnancy, glucose, BMI, diabetes pedigree, age, skin thickness, blood pressure, insulin. Each of them we have 9 features. So there's going to be 9 inputs. There's going to be 9 neurons here. All right. 1, 2, 3 plus 6 more. All right. Then the hidden layer, there's no limits to what we want to do. But as we go further, we'll try to understand how we can set this up for success. Because if there are 6 means this one, the hidden layers will be more. And the layers could be more also. So at the end of the day, what turns a linear prediction into a sigmoid prediction is called activation function. All right. So essentially, what goes on here could be quadratic, could be linear. At the end of the day, the activation function, how do I break it down? I kind of want to break the activation function in a way that you will recall. So it introduces non-linearity. Introduces non-linearity into your data and helps you to transform the non-linearity into a sigmoid function kind of. So let's say back propagation, right? Like I mentioned earlier, where your models goes both forward and backward. So it's trying to find like the best combination of neurons what enables that backpropagation to occur is the activation function. There are several activation functions. Another thing you want to know about, I think I mentioned it, it enables the layers to be able to learn nonlinear relationships. So what makes deep learning and neural network particularly interesting is, while for machine learning, the process is, the model actually does its prediction practically linear. Deep learning can go both ways, can both linear and non-linear, and still allow the same prediction. All that is possible through the activation function. So it enables it to learn non-linear combinations. It tries in creating our features, right? There was one thing we noted, that you can add polynomial features, right? But in deep learning, because of the presence of an activation function, most popular is ReLU, it's rectified linear unit. You're able to learn non-linear patterns in the data without actually telling it directly to learn the non-linear patterns in the data. That's what makes it very powerful. That's what really makes it really, really powerful. So you're able to learn non-linear patterns in the data. Remember where we came from, that I was saying what we're essentially doing in prediction is to learn the patterns of the data so we're able to make future predictions, right? So deep learning, by the help of neural network, is able to learn non-linear pattern using an activation function. Why non-linear pattern? Because the world around us is never linear. So in order to bring the best out of any data point, you need to learn the non-linear relationship, and deep learning neural network helps us to master that through the aid of backpropagation that's possible through activation functions. I know I'm rambling a lot, but if you have any question, please ask. Okay, zero means this explore more on activation function. Yeah, that's why I was spending the time to do that. There are several activation functions, right? Usually you find activation function in the hidden layer and the output layer. If it's a classification task, sigmoid function is usually the activation function at the output. But most of the hidden layers we use or liquid. There are several extensions of the activation functions we can use, right? There's TANH, there's softmax, there's liquid, there's so many of them, depending on the case you're trying to resolve, right? So I know this is probably a new concept, and if it's not clear to you, I won't be able to texture where your understanding is, but I can help you if you have any question. That way I'll know what you're actually struggling with. But in summary, deep learning uses a method called neural network to make predictions. That's one. In building a neural network, there are three layers: the input layers, the hidden layers, and the output layers. Now, what connects the input layer and the hidden layer and enables the architecture to learn nonlinear relationships are activation functions, right? And activation for this nonlinear relationship we can't really tell what it is like, but with the help of back propagation, the model moving forward and backward to learn until it arrives at a convergence. That is possible through activation function. Then when you get to the end of when the model is done learning, it wants to make a prediction. It uses another activation function. Now, if it is a linear problem, still a regression problem, you can use softmax. If it is a classification problem, you can use sigmoid, right? You can use a sigmoid activation function, right? I think softmax and both sigmoid can use can serve for classification problem, I think. Yeah, can serve for classification problem. Okay. Okay. The neural network based on the activation functions. Okay. So let me go back again. Let me try to but anyone has any other concern? Any other question? Any other concern? Any other question? No? Trying to get what an activation function is. So let me see. So if you can see my screen, let me duplicate this. With more context here. So yeah, I don't want to design anything. So look at this, right? There is more I'm still not seeing with neural networks. There's more I'm still not seeing. um, I think the slide or the slide, this is helping me see what to improve on with the slide. There are things I'm actually missing a bit here. And that really were included. So there are weights, there are inputs, there are weights. And the activation function, what it does, it helps the model to learn, right? What it essentially introduces is non-linearity. It introduces non-linearity. It helps the model to learn non-linear pattern. It tells the model that, look, there could be a non-linear relationship between the inputs. Go learn it. That's what the activation function does. Go learn the non-linear relationship that exists between the inputs. All right. So the non-linear relationship is like complex patterns, right? So in our own case, diabetes and let's see in the input, right? Let's see pregnancies and blood pressure and skin thickness could have a relationship, right? But while learning it from machine learning, we are not able to establish that relationship exists because it's just modeling a linear relationship. But because of neural network and the presence of activation function, we are able to explore potential nonlinear relationship that occurs between the input to be able to produce a robust output. So what makes it possible to do that is the activation function. I hope that's clear because in the real world, data is not linear. Real world occurrences is not linear, is non-linear. So tries to learn that non-linear relationship with the help of an activation function. Does that make sense? Just to check non-linear relationship. Yeah, non-linear relationship. Yes. So that's what the activation function does. All right. So there are many types of activation function. You can go linear. You have linear activation function. You have non-linear sigmoid, sandwich, and the likes. Right. I hope that helps clarifies where we're going to. I can still pull up in my elastic limit. So we've talked a bit about activation function, and we said neural networks. The primary approach to deep learning is neural network, and there are three layers. You have the input layer, you have the hidden layers, you have the output layer. Without diving into the mathematics of weights behind each of the layers, behind the input layer, the output layer, and what have you, right? Third, driving into those mathematics, we simply move from we learn the different relationship that exists in the input with the help of the activation function, right? That's what I want us to hold on to for now. And so, how do we basically, if you have the understanding, you're on your way to like building your first deep learning model. I think you're on your way to building your first learning model. Once you have the understanding that there are three layers, the input, the hidden, and the outputs, what connects the different hidden layers to the inputs and enables it to learn nonlinear relationship is the activation functions. What connects is still the activation function that connects the hidden layer to the output layer. But in this case, it is determined by what you want to predict. I think I mixed it up the other time. Not really mixed it up. Both softmax and sigmoid uses classification problem. Softmax is for multi-class classification. Sigmoid is for binary classification. Linear predictions doesn't really have an activation function. Right? If you leave it blank, it's going to predict continuous output for you. So that is that. So one thing I want to point out is don't go build a deep learning model for a task that XGBoost can perform. The reason is this. You see how the neurons are mushed up and all interchanging with each other. And you could build something that has more than 2 layers or 3 layers. Now becomes a black box. You are not able to explain what is going on. And explainability is a key concept in AI of today. So as powerful as these models are, there's always a caution like, can we do without it? If yes, then don't bother. If it becomes very necessary, then go ahead and do it. Because of explainability, you want to be able to tell what actually went in here per time, right? It's difficult to tell for a deep learning model as compared to your classical machine learning model. So unless it becomes necessary, focus your attention on what works. For more complex tasks, yes, NLPs, image classification, you obviously can't help but use deep learning models, right? Yeah, okay. It's all that helps. So how do we now build this model? Like I said, there's a bit of maths around it. I'm not going to like deep learning in Python follows almost the same approach. Popular libraries is the TensorFlow, Keras. Keras actually owns TensorFlow, right? Or TensorFlow hosts Keras. There's PyTorch. I use TensorFlow and Keras most of the time. There's compile, there's feed. So you see here, there's different layers, rather different hidden layers, input layers, hidden. What they compile does, is it compiles all the layers together, then it fits it. Remember, if you recall our machine learning model, we had to fit the model, to train the model, we had to do model.fit, filing each of the layers together would fit the model. After fitting the model, similar to machine learning model, what we are trying to fit for in deep learning is to reduce the training loss. We are trying to train a model that reduces error. So the training loss should be as small as possible. What that simply means is that as close as possible we are to the correct prediction. It shows in how tiny the error the model is generating is. Smaller errors means better predictions. I think that's what's really I'm trying to pass across. Smaller errors means better predictions. So how are we able to do with better predictions? This guy is almost always prone to overfitting. Deep learning is too, it loves overfitting because it's a complex model. It learns complex patterns. It can go spaces. It can learn into spaces that you don't even envisage possible. So that makes it highly prone to overfitting the data. To prevent that, you want to look out for, these are all approaches that you can use to prevent against overstating. So dropout, get to a place, drop out some number of layers. Don't train on some number of neurons. Early stopping, if it reaches a certain threshold, stop. Regularization, introducing penalties as it fits. Introduce new penalty as it fits. Introduce new. So it's sort of like clipping the model. I'm telling you, don't get too excited. Keep clipping, clip normalizing, keep normalizing until you arrive at. So importantly, monitor training versus validation loss. What we say we want to do is to minimize training loss. So ideally, if you test your model, both should be going down, not up. That's one way to show that your model is not overfitting. Still any question? Just enjoyed machine learning and you're now wondering, what's this one? Or what is this one? I thought that I have a handle of what is going on. And I have to deal with this. What's this one? I thought I'm enjoying it. So let's look at how do we implement it importantly. How do we implement it? So we usually say we use I don't think I want to install this. Clearly, there's work to be done on my end on the slides. I apologize for that. I would maybe not for this section, but you guys definitely have given us work to go do on the slides. We'll work on it. There are some aspects I'm actually skipping. There are different approaches to building deep learning models. I stuck with sequential because I feel it's kind of what is in vogue, and a lot of persons could relate to the whole lot. I need to update on the slides, probably for the next cohort. So that's giving me some tricks to go work on. But yeah, I hope it captures able to take some things out of it, out of what we are doing. But this is possible, trying to capture a few things. Okay, and helping you kind of start off building, right? So I actually didn't talk about the different types of deep learning models. There are different types. I didn't mention that out. I went straight to building it, right? I want to like go explore. There are different types of deep learning models, just like there are different types of machine learning models. There are different types of deep learning models. CNN, is it? Yeah, convolutional neural network for image classification and for video classification, for spatial recognition, and all that. You have transformers, which was used to develop LLMs, large language models. They're basically transformer models. Have recurrent neural networks, which is good for time series analysis. So anything that has a memory of future events, of past events, taking it into the future. You have recurrent neural network. You have long short-term LSTM models. So an advanced form of RNNs, it has git can retain and recall information longer than recurrent neural networks. You have GANs, generative adversarial networks. You can read them up if you want. You have autoencoders for basically, I use them for translation. I use them mostly for translation, autoencoders, compress input data into, reconstruct and all that, encode, decode for translation. And I think deep reinforcement learning as well. So, oh, you leave? Okay. Reinforcement learning and what have you. So there are more you can explore. What we just presented is a fine grain of what you can quickly do and you can quickly get your hands to do. Fortunately, we can cover so much so it doesn't throw you off. And touch that thing again. But this is to kind of give you an overview. There is more you can learn. There is more to go research on. All right. I think there's a book I would recommend, Deep Learning with Python. That's one book I have in my library that helps break down the different types of deep learning models and how to build them. Deep Learning with Python. I've forgotten the author now, but I think it's a French. I don't know. But you can go look up that book. Let's see. Python. It's Python. Yeah, this one. Just short. Yeah, it's a French name. Deep Learning with Python. I think it's a good book that you can. I think they have like a GitHub page for it. Yeah, they have a GitHub page for it. So you can go look it up. Different machine learning models and how to build them. The mathematical blocks, the introduction to Keras and TensorFlow, get started with neural network, fundamentals of machine learning, universal workflow. So, yep, deep learning for time series. Yeah, it talks about recurrent neural network and computer vision, generative deep learning, best practice, conclusion. So if you want to go explore deeper, that's the reference material you can look up. It's free online. It's on just 466 pages of learning. It's deep learning, 2 layers. What did I load first? TensorFlow from Keras, from TensorFlow import Keras, from TensorFlow import Keras as model. So, not just sequential model that is available. You know, there are other models you want to look at too. But these are just the building blocks. We build it in sequence. So input layer, hidden layers, um, output layer. So what we built is a neural network with 2 hidden layers. The first layer has, outside the input layer, the first layer has what's it called? 16 neurons. The first layer has 16 neurons. The second hidden layer has 8 neurons. Right? Both uses a ReLU activation function to learn nonlinear patterns in the data. And here is the output layer. And the activation function is sigmoid because we are predicting a binary outcome. Right? So what we've done is to build the model. So how do we tie them together? We compile them. What we are trying to account for is a binary loss and cross entropy. There are so many loss functions. So we are trying to minimize the error. Remember in linear regression, we looked at mean square error. We are trying to minimize the error between the prediction and the actual class, the prediction and the actual group. Here we are also trying to do the same thing. The name of the error here is the binary cross entropy. And how fast this gets done is a function of one of these an optimizer called Adam. These are the bits and pieces that I'm kind of skipping, and I hope you kind of go check it out. What's the metric we want to track? We want to track the accuracy, right? We want to track the accuracy if it's optimizing the binary cross entropy. What accuracy do we have? We could see the metric the model is generating, and that's accurate. You could decide to go for precision. So actually, let's try. Can we do precision? Precision was low in the previous model. So if we check the precision here, what will it look like? So I've also, to prevent overfitting, I've introduced early stopping. Like I'm telling the model, if the validation loss get to a certain threshold, stop. Stop, don't go too far. And what have I done? Is now, after defining all this, I fit the model. Impute, these are the data, X train, scaled, Y train. Where's the X train scaled coming from? Back up here. X train scaled. Where I did the transformation here. So it's just the same data. So Y train as well, the epochs, number of times the model goes into the data, the batch, what's the batch size, that's to still validate it, callbacks, show training progress. So when I run this, looking at precision, it should be increasing, right? It should be increasing. But here's the problem. The loss, look at this. It's not an improvement. The loss was 77%. The precision was 2.9 at start. The validation loss was 75, higher than the training loss. The validation precision was 3, so it's actually losing. It started losing, but it got to a point it's increased. Around here, the validation loss dropped here to 0.5, which was good. The precision, training precision increased. The validation loss also dropped, which is great, and the validation precision increased again. That was good, but as we trained further, the validation precision decreased again. Why did training precision increase? It's kind of overfitting. So one thing I can do is I want to reduce the number of epochs to say 80. I think it's overtraining. And let me run it again and see if it's gonna be an improvement. I can take 60. This was reducing. This was increasing, reducing, increasing, which is kind of good. So what else can I do? I can say the size of the training. So let me reduce it. Just take a random figure 30. Breaks it into 30 different batches. And that's terrible. So it didn't make any improvement. It just went worse. So if I increase the batch size, it's gonna. These are all hyperparameter tuning that I'm just trying to play around with. Batch size, is it any better? Let's see. Some profit, but this is still too high. Right. The sim 32 is like the sweet spot. Probably like we had some notes here. Use scale training and testing epochs, number of training iterations, number of times it trains before it arrives at the conclusion. Batch size is the number of samples. How many samples does it take per training per update? It does 32. We already know about validation data. Callbacks are usually like metrics for defining for preventing overstock or overfitting, right? You see, the interesting thing was it previously worked good the last time, but even with the 32, um, the 32 batch size, it failed this time around. Didn't generate the same result. So in some cases, you want to do this. You want to just you want to just keep a random seed so that you're able to replicate the same result over and over again. So you take the good results. After fine-tuning your hyperparameters, you end up taking the better result. So you stick with that. You see that it's 580, 5833. If I run it again, it should give me around 5833 and not jump everywhere. When I run it, it seems to be doing better, but I'm careful. What is the sweet spot? That's the problem. These models are probabilistic. They're non-deterministic. So you have to like keep finding the sweet. Something is obviously influencing the output you're seeing. If you want to go explore and debug why that is happening. So yeah, at the end of the day, the loss is what 53. The accuracy, the precision is 60 because we are optimizing for precision. Precision is 60%, which is better than what we had earlier, right? I think we had 57. We had 57 earlier. Let's see. It is a huge improvement over what we saw in logistic regression. This is actually like not the great model, not a very complex model, but there's an improvement. The same sample size. We had 57, we have 61. So there's an improvement. We had 25, we have 31. So there's an improvement in the model. Using a different model, there's an improvement, right? These metrics are still within, I think the recall was 50, is 57, the precision was 57, 60. So there are improvements, right? And if we go ahead and tune the model a bit more, we're gonna get even better results. So that is the advantage of going for a complex model, but you want to do that only if necessary. You want to do it only necessary and not just jump to it because it's available. You want to do it because it becomes necessary for you to do. This precision, we're dealing with string precision. Precision is good. Validation precision is close there. It's still precision. Sorry, I can't label everything. But loss, epochs is good. So almost the rock curve is almost the same, like the logistic regression model. There is room actually for improvement, but we could tell that the false positive and false negative prediction has dropped. And the true positive prediction has also increased. While this still stays, this has also considerably increased a bit. So if we push it further, we can get better predictions. So this is just an overview of deep learning. I'm just trying to show you that models are not one size fits all. You can always improve their performance by looking at other options. But your part, there's still much more to be done. Obviously, if I were to build this in production, it would take running several different, with the help of cloud these days, you can run several models in parallel and end up choosing which one is the best. But I'll pause here. I think I'm pretty much done. Yeah, pretty much done. If you have, excuse me, if you have any questions, comments. Still comments? Yeah, please go ahead.
Okay. Can you hear me?
So,
Okay, thank you. Thank you so much for your time and the explanations. Not really concerning the deep learning. You just curious about something I want to remind. You mentioned a text when we're doing machine learning, a textbook, a book, and
yeah.
yes. So I don't know if you will be able to share that with
Yeah, I
everyone.
think I shared the one for
And this one is
deep
for deep learning.
learning.
Yes, sir.
Let me see if there's a free version for, I think 207 something pages. I think that's the same size as what I have. Let's see. Really, really cool. All the models we talked about, overfitting and underfitting. If you see this, what does it tell you? This is the model trying to overdo. This is overfitting, right? This is overfitting. Different learning rates produces different overfitting. Low learning rates, high number of estimators results in overfitting. It's not just, it only tells you the code, it shows you the code as well. It shows you the other stacking. This was the one I built for my project. I stacked a couple of machine learning models and tried to compare them with a deep learning model. So what I essentially tried to accomplish was try to build a neural network that is not a deep learning model, and using the prediction from one subset to make predictions in another subset. So I was essentially using output from one group of models as input to the next group of model. I think I had 3 different levels. Then the third level was the final output. It still didn't, it still didn't perform like a deep learning model. Cost of dimensionality, sparse. This is a good textbook. I think I'll do a refresher on it soon. The I didn't talk much on PCA, but I'll share this with you so you can go read it up if you want. Unsupervised learning techniques, we didn't talk about it, clustering. different, I think I mentioned different clustering groups, you know, between variance must always be high. Within variance should be low. How do you determine if this number of clusters? There's the elbow method, there's a silhouette method, yeah. There's the elbow method. You can use the silhouette score to determine what is the best number of clusters. There's the limits of k-means and semi-supervised. Yeah, there are other methods we didn't touch, but you can read it up if you want. There's still much, like, you just keep learning, really. Yeah, that's the problem. I don't think this is everything. This is everything. It stops at clustering. I was surprised that 270 something pages, the one we have is bigger. There's another one. Pages. I don't know if this is everything, but I'll share this GitHub with you guys if you guys want to go take a look. Just on the textbook. This opens, I think. Yeah, I'm gonna share the link to the presentation. Although I wished I went deeper into the deep learning. I don't think I did so much. I went deeper into it as much as I wanted. So yeah, I think I can share this with you guys. This covers deep learning, which one? I think that's great. So I can share this with you guys. So I'll just put the link in the chat. Talks about everything we've try to bring your attention to. Convolutional neural networks for image classification. Pulling images are essentially stacks of layer, pull the different pixels to predict if it's a cat, cheese. Yeah. This is what you want. Okay. I don't think anyone has any question for me anymore. I think the rest of the slide, these are topics. Okay, this is actually my two areas now that I mostly work on: fairness, bias, accountability, and responsible AI. Essentially what I do is I look at a model and I kind of possibilities associated with the model, and is it responsible to those governance requirements, and consistent is the model in production over time. So those are things that I kind of focus on these days. on. I think I provided you with some materials you can go look up. So thank you very much, and blessings.
Thank you.
Yeah, I think the training officers, you guys can take it once. Yeah.
All right.
That,
Can you all hear me?
yeah, I'm done.
Okay. Thank you. 1,000 thank you to Mr. Roland Abi for such a wonderful exposition and moment of deep lessons in machine learning. Thank you very much for also honoring our invite. I want to thank those who were able to stay put up until this time. I want to believe that you've gained massive value and that beyond this class, you'll be able to make sense or put the knowledge to work in such a way that you become a positive ambassador of the NELIREF objective. I want to thank those who have been working behind the scenes. Some of us who are in the comment section responding to various inquiries, and those who are not even live, but they are doing something to make sure this program continues. Thank you so much. I want to also implore us, those of us who are still onto our assignments, make effort to submit those assignments between now and the deadline so that you can have the opportunity to get evaluated on what you're doing. The most important thing about learning a new skill is, if you ask me, I would say it's not only knowledge acquisition, but the opportunity to get mentored, to learn from other people. So you are part of a community of people who would provide you ready answers whenever you need them. You can always make your inquiries on our social media platforms, Facebook and Telegram, or you can send us an email via our email contact@neliref.org. And we'll try as much as we can to respond to you promptly. I don't know if there's anyone that has any particular contribution, question, something that you just want to get off your chest. I'll give that opportunity to you in the next 2 minutes. Otherwise, we have come to the end of data science and AI summer school, and we can now part ways. So I don't know if there's anyone who has something to say. You can go ahead and say.
Hello, can you hear me?
Yes, I can hear you. Nothing.
Okay, yeah. So I just want to appreciate the NELIREF team for organizing this summer data science and machine learning program. You know, some of us who are students, this is it has given me a kind of like the foundation to go and explore more, possibly in the future, to go deeper into these kind of areas. Because if you want to go and start maybe Python programming and you're just hearing of it, maybe very big, very hard to come by. But with these basics now, you can then just watch the recordings again and again, and then you can pick up. And also, by attending this program, I think I have people that I can
always get back to and say, please, I have a challenge here. Can you come and help me? And I will always have help. So I just want to appreciate the management for this. And on behalf of all the participants, appreciate you and thank all the facilitators for their work, the work that they have done in these 2 weeks. Thank you very much.
Hello.
Thank you so much. All right. Thank you, Mr. Daniel. Next person, Zongwem Teima.
Okay, sir. Yes, sir. Good afternoon, my brother and fellow participants. This is Zungone from Benue State, Nigeria. I wish to first of all thank the Almighty God for keeping us alive to witness this program and the team leader, Brother Joseph Lopetsenu, who in his compassionate manner to extend the knowledge he has garnered to some of us. It has been my earnest desire to learn AI in the university at the master's level, but time and financial resources has been my constraint. And with being part of the NELIREF Foundation by Joseph Tenum, I have been able to get a vast knowledge on AI and data science. Even though I was somehow down with stroke last week, I could not follow up again. I can watch the videos over and over and then follow up using my system. I wish to appreciate you, sir, and your colleagues for giving us an in-depth knowledge about data science and artificial intelligence. I wish to pledge and promise that we will make good use of this knowledge we have gotten from you. It will not go in vain. And I hope that tomorrow you hear from us that we are making good use of this knowledge. Thank you, and God bless you, sirs.
Thank you very much, Teima. The next person is Rokib Aziz.
Good evening, everyone. I want to especially thank the team for putting this together for us. Thank you very much. May God bless you. We really appreciate you for everything you have done, the coordination, and everything, your time, your resources, everything you have put in place to achieve this. And most importantly, you even make resources, material, and the video available to us so that we can go over to it after the training. Thank you very much. I really appreciate that. However, one of the most important thing that even you can be proud of in this training is that after the training, you should be able to continue with it. I understand that a platform has been provided for continuous interaction after the training. However, I want to appeal that the team should provide a kind of internship opportunity, especially remote one, for anyone that is interested, so that it will help us to continue reshaping ourselves in the field. Thank you very much. And also, I want to appeal for attention on the submission period for the task so that we can go over over on the video and be able to do all the tasks given to us. Thank you.
All right. Thank you very much, Rokib Aziz. That was well noted. Next to Chicha Tengu. All right. If Chicha is not available, Ba Solomon, please go ahead and.
Yeah, good evening, everyone.
Good evening.
Appreciation goes to the organizers of this summer school. I'm Solomon Ba. I joined NELIREF long time ago, I think 2022 or thereabout. And I don't understand how I missed the last year's session. And I must say this has been very, very interesting. One thing I want to say to my fellow students here is that this opportunity is free, but we shouldn't take it for granted. I remember in 2022, I enrolled for a 4-week training on Python, and it cost me 24,000 that time. So there are other people who are organizing such trainings, and it's very expensive. This training we received here, if we are to pay for it, I bet you it won't be less than 50,000. So we shouldn't take this for granted at all. And again, why did I come back? I come back to this summer school because since completing the Python session I had in 2022, I was not able to practice what I was taught consistently. I abandoned it completely and went out hustling, like most Nigerians will say. And in the end, almost all that I learned left me. But coming back here, my memory has come back. I've remembered all I was taught, and I can go on and on and on and practice in my own free time. So I want to encourage everyone who participated here. It is not all about the certificate. They may give you the certificate like I had mine since 2022, but if you don't have the skills, once the skills are not there, your certificate is as good as useless. So I appreciate the organizers. I encourage my co-students to please give their attention to practicing this. Good enough, we have been given a lot of hands-on materials to practice. And again, we can go to the internet, we can go to YouTube, download videos, watch them, and practice continuously. Those are the things I was told in 2022, and I failed to do them, and I keep regretting. So for me, this opportunity is one I can never take for granted. Thank you very much.
All right. Thank you very much, Ba Solomon, for that wonderful submission there. I don't know if Chicha Tengu is up now. Otherwise, Abba Sunday, you're going to be the last person we'll take statement from. And then I'll give room to the director to give his closing remarks. And that will be all. Thank you.
All right. Thank you so much for the opportunity. So, first of all, I would like to appreciate the facilitators and the organizers of this program. This 2 weeks program has actually been helpful, like to most of us, honestly. So, I would like to appreciate everyone that actually come together to bring this into reality. And again, I just want to make maybe an appeal. If actually like most of this after this program session, so that if there can be a follow-up project works that can actually be sent to some of like most of us that actually participated in this, it will actually help us a lot in this consistency of a thing, and at least giving us more practice to real life projects, like working with real life projects. I'm even suggesting if we can even have I don't know if we can actually like we that participated in this particular session for this year, this 2026, if we can have a WhatsApp platform so that like consistently the admins can be sending us real life I say yeah, like practical project to work on, so that at least it will also build us up in, especially in it will train us more in this field. So that is just my little suggestion, and I will really appreciate that. Thank you all, and thank God for everything.
All right. Thank you. For want of time, I am not going to proceed with giving others the opportunity. I wish we have more time. We'll take statements from everyone, but we would have to stop here. Just a few important things to note. You're going to receive follow-up information after this event, materials about the assignment, and also if there's going to be opportunity for minor, let's say, pilot projects that you can dirty your hands with while trying to learn or get mastery to the skill you just acquired. So we'll inform you about all of that. I don't know if the attendance sheet has been shared, the link has been shared in the comment section. Has it been shared already? Okay. I think it has been shared. Please do well to fill the attendance for this evening session. I just shared a fresh link. I don't know, someone is complaining that the attendance is not labeled correctly. It's showing morning session. So just go ahead and click on this new link. Then, like I said, we are going to communicate with you afterwards. But more importantly, we would like to hear from you in our social media handles, particularly our Facebook groups. I would like you to share your experience while you're learning and ask questions there. The recording for this video is going to be up on our YouTube channel in the next under 24 hours. You should find it there. And so if you still need to make some reference or you still need to rewatch it, please go ahead, look for New Life Research Foundation and locate this particular video for day 4 of week 2, and you should be able to find it with ease. So once again, I want to thank you for the patience, and I want to thank you too for the resilience. It's been close to, I think, 6 hours or so. We started by 8 a.m. and we are here 4 p.m. West African time. For those joining us from different time zones, I know it's going to be anything around maybe 10 a.m. where you are, or depending on what country, by the way. So I want to say thank you. Thank you so much for believing in us and for holding up to this time. It's Fredalin Anipa once again, and I'll be handing over to the director now to say his closing remarks. Thank you.
All right, thank you very much, Fred, for that opportunity. I want to thank everyone for joining this summer school. We had our first summer school in 2024. We had the second one last year, and this is a third summer school. And in all these years, we've not done the summer school without challenges. We've always faced challenges, but we are learning from all the challenges that we face in each summer school. This summer school came with its own unique challenges, and we noted them. We're going to implement them in the next summer school. For those of you who joined us in 2024 or last year, you observed that the summer school was held in just one weekend, which was very compacted. Everything was just compacted. We didn't have enough time, and we struggled, but we learned from that, and you also learned from that summer school. You got the basics and you started practicing and learning everything. So we had this year we took your feedback. The feedback was very important. The feedback we gave you last year, I mean the feedback you gave us last year was very important in working on the program, modifying things, and ensuring that we implement a better program. We have a better summer school this year. We're having a better summer school this year because of your feedback. We decided to have this summer school for 2 weeks. And why we have it for 2 weeks is because of your feedback. We took your feedback. Those of you who were there last year, you complained of time. Time was not sufficient. You would love to do this. And we all hear you. We hear all your comments. And we go back to our meeting when we have our annual leadership meeting. We look at the whole program and we try to adjust things and incorporate your feedback in the next summer school. So we're going to send out a feedback form, and for those of you who want to also upgrade your score or whatever, you want to also get bonus points, you can do it by completing that feedback form. We're going to send out the feedback form in the course of this time between now until July 28th, because that's when we finish grading all the homework and all the projects. So I implore you to complete the feedback form because it will help us to work on those things that you're all discussing. And we don't have enough time to give to all of you to um, air out your your views, your comments, your good feedback on what we need to improve, what we are doing well and what we need to change, and a lot of things. So put together everything, and we give you a room for you to make a comment. And your comment in the comment we give you a very large space to type whatever you want to type, and we hear you. We read every comment. We read every comment last year, and the modifications you are seeing, even for us to be using Luma, even in communicating with you, you can see the registration platform is not like a Google form. And so we took that feedback last year and we improved on even registration for this conference, for this summer school. So we are actually improving. We are improving on our methodology, our teaching methodology. You may notice that the one of last year or the last 2 years were more faster because of time constraint. But this year we took a lot of time explaining basic concepts. Were very slow. It was deliberate. For some of you who are already in the field, you may notice that we're too slow, and we knew why we're too slow because we listened to your feedback and we tried as much as possible to hold your hand to get some of the basics. And we do also understand that for some of you who are starting this for the first time, it can be very challenging. You are hearing this concept for the very first time, and that can be challenging. But we want to congratulate you for doing a wonderful job. You did well for staying to this point and learning all these so-called hard concepts. But they are not actually hard, they are not difficult. But we want to also implore you to learn hard science. So that's what we do here. We learn hard science. So we will recommend materials to you for those of you who wanted to learn math or machine learning. We will recommend very good courses for you to learn linear algebra and all the math of machine learning that you need to be able to understand the basic math, because all this is happening at the background, at the back end, and there is a math that is going on at the back end. And so we want you to be able to have understanding of those math. I took a course at Georgia Tech on math or machine learning. I still have all the materials and all the recordings on my local computer here. I can send them to anyone. Just shoot me an email, or you have our email, you have our website. You can do that if you want to dive into more difficult concepts. We're here to help you. We're here to hold your hand and see how that we come about. But also want to appreciate our instructors. They've been here in the United States. They got up so early. That was 3 a.m. So getting up 3 a.m. Roland got up 3 a.m. and he has been teaching since morning, and he's getting to afternoon here. I want to thank every instructor. The TAs are always in the comment section answering questions and trying their best to ensure that the learners get everything they need to get them started on this journey. I want to thank all the participants. You maintained decorum, apart from the first day, which we had some challenges, but after that, some of you were using Zoom for the very first time. We do understand that, and you've all kept to the basic rules. I want to appreciate you, and you're all doing well. You're all doing well in the quiz. The quiz we're sending out. I think the list we had on average is the average score should be around 80%, which is a good score. So it's but we are also not we are not going to rely on that metric. What is most important to us is the feedback we are going to give you on the projects you're submitting to us. And you will do yourself good to spend time with all the materials we've sent to you, all the presentation slides, all the Jupyter notebooks. Spend quality time with it. Don't assess yourself based on the quiz. Yes, a quiz will get you started, whether you were participating, you were listening, you got something from that session, or you didn't get something from that session. But the main work is for you to discipline, and we lay that right from the beginning. It's for you to discipline yourself and go over these materials again and again. I'm almost 7 years in this space, but I still have my notes, my handwritten notes, which I review from time to time. And I follow things from time to time. If I'm not doing that, I'm going to lose everything. If Roland is not doing that, he's going to lose everything because things change every day. You see the Copilot, things are going to be changing every single day, every single week. You will see new inventions. And I gave an example the other day that we have prompt engineering. Before it was prompt engineering, now we have loop engineering. Everything is loop. Loop engineering is everywhere. So you will see things are changing. Things will continue to change. So the good part of this, our joy will be that you spend more time with these materials and you're able to get back to us to see that you understand these concepts and you're able to follow that. So that's on your side. And then someone mentioned about communication. Yes, and then I'll come to internship. Someone mentioned about asked about communication, and then internship. I'll come to internship after speaking about communication. Yes, we have social media platforms where you can reach out to us. Make a post on Facebook, we answer you, or go on Telegram if you're on Telegram. Answer any question there, we are going to answer you. But also, most importantly, we have a website, and we just recently recruited some website developers, and some of them, I think, the two of them are also part of this summer school. I think one of them took a permission because he's writing exam, but the two of them are also part of this summer school. So they are going to be managing our website. We have a website, and you all are aware of it. If you don't know our website, someone will type it in the comment box. Go to our website and sign up. We have different groups there. We have summer school, and I'm going to quickly share I'll quickly share my page, my screen. I mean to say, I'm going to quickly share my screen, and then I will show you that quickly before we leave, so that you can go there, sign up. We're trying to have a mobile app. Very soon you see the website will have a mobile app, and once you have the mobile app, you can be able to visit us on that website. So go to New Life Research Foundation.neliref.org, and this is our website. It will take you to this website. It's our website, and from here you can either sign up. You can create a free account here, or you can sign up. I think at the top right, you can log in here with your Google account, or you can get started from here. So either here, over here, or any of this, or here. And with this, you can be able to go. This is our landing page. This is just our landing page with everything and all the social media. Or you can see all the social media links. You can be able to join any of this. But also, most importantly, another communication platform is this, because we're working seriously on the mobile app. So hopefully we should get it into your hands, or the web app. This is the web app section of our website. And here you will sign in, you'll be able to sign up. And you see, you can continue with Google. I'll continue with Google and sign in with my Gmail account. You can sign in with your Gmail account. I'm just trying to sign in with my Gmail account. You can see it's signing me in. You can do the same thing, because we have groups that we created, and we want to communicate with you as much as possible. You can see some of you signed up on this website recently. Chika, Krishnan, and all these people signed up recently. We can see them here. They signed up recently. But you see, when you come to this website, when you come to the web app, this is a web app. You will see, you click on groups. Forums are for leaders. They are not for you. But when you click on groups, you will see different groups, and you can request to join. We are ensuring that all functionalities on this side of the website work. Some few things are broken, but we have the volunteers who we interviewed one of them, I think last 2 weeks, and he just joined us. We had a meeting with him last Sunday, and he's going to take over to fix some of the little things that we have on this website. And if you're a consistent visitor of this website, you must have observed that even the landing page, there are changes on this landing page. we're not having this sort of like slide show or whatever. But you see, this change was made recently, and a lot of things were made on this. If you go on our gallery, it was not as beautiful as it is now, but okay, you can observe that things is more organized now than it was before. So we consistently work on this website. Our focus is now on the web app. So on the web app, you can be able to join different groups, tech podcast, and we have a lot of volunteers. We have over 60 or almost 70 volunteer leaders. And that's some of you are part, some of our volunteer leaders are part of this summer school. And we want to thank you for volunteering with us. And now you see there is a lot of responsibility. There is a lot of work for you to volunteer with us and keep doing what you are doing, how you are pouring into this work. We appreciate that. But now you see there is a need for us to keep interacting with these ones that are just passing through the summer school. So here you can be able to join different platforms. You can see the Interlab team. You can see past scholars. If you're a past scholar or you secure a scholarship, we have over 600 of our members who secure scholarships. And some we have a Telegram group, but also we have this group as well. You can join us. We're ensuring that these groups are active. So we try to engage you, and if you come visit it, we'll all make it active. It's not going to be a one-man thing. If we all want it to work, because if I post there and no one comments on it, or no one, the groups are not going to be functional. So we need you and our leaders to be able to make those groups work. So here you will find I'm just walking you through to be able to identify the group that you belong to. We've already created this because right from when we were building this website, we had that in mind. So we have you can be able to join different other things and benefit from this. You can see we have an undergraduate scholarship department where we mentor people. You can read more. But you see, we have training, professional, and personal development platform. This is where you can join us. This is a group specific to you. This group is responsible for training our members to acquire top-notch professional skills in all disciplines with emphasis on tech skills, which are right here, and personal development skills. So this is a group you will request to join. You can click on this, and then you will be able to join this group. But you see, when last I posted on this group in January, that was in January this year, I made a post here. But it's been, we don't really have people done. We need you and I to come on this platform, but also we are going to ensure that everything works, all the bugs that we need to fix to ensure that everything works without issues. We try to fix that so that you will be able to communicate on this platform as well. Not only that, if you keep going down, I think you will find more groups. You can see follow-up, discipleship, and Bible study. You will find Department of Humanities, computing, and now you can join more platforms and learn from different platforms. If you belong to computing, if it's humanities, if it's sciences, you have there. If it's management sciences, if it's architecture and planning, you have there. If it's engineering, you have there. Interdisciplinary lab team. We have different groups here, and you can benefit. Financial small group, we have them. We have head corner. We post things that will benefit you. Discovering your purpose, free ebooks, and all this. These are all resources we have. You can see we have a lot of them. These are more resources. We have startups, how you can get yourself acquainted with all this. So this is a big vision that you can actually benefit from all these resources that we have. We have, if you want to join our campus visitation team, you can join and inspire young people, inspire college students, university students to know our vision and to be part of what we are doing. Because if some of you and you and I maybe if we came across this kind of platform or in the university, that would have been really, that would have changed our lives. That would have taken us to a different step. So we have this group who reach out to universities and organizations. You can actually join them. So this is all I have here. I've shown you where you can go and join. Apart from our social media platforms, you can be able to join that group. Let me see if, okay, we have the website there in the comment box. You can be able to join. So having said that, I want to thank everyone. And then the second part of what someone asked about internship. So this is what we are doing as an organization. We are applying for grants, and just last 2 weeks, we entered into partnership with the African Bioinformatics Institute. It's based in South Africa. For those of you who are interested in something like that, we entered into that partnership with them. And so on that side, we're also going to be pushing things to organize more training. You will see more training sessions will be coming up. We advertise training programs that we co-organize together. We will put them on our platforms, and you can be able to join. You join more technical programs, and we have some um, we have it could be something like financial literacy 101. We can have something like bioinformatics 101 or something like that. It may just come up, and you can join and learn from the partnership we're having with different people and different ministries, Christian ministries as well, and also labs and institutes. We are looking at expanding and working with more institutes to expand our impact. So for internship, we don't have it for now, but we look forward that with time we will make this. It's not just going to be, yes, we can keep this program, but let's not just keep our focus only on this. Let's spread it over the year. Let's try to check our members' understanding. Let's organize weekends, like we can have weekends of Python programming practice, and a lot of our members can join. We can have those kind of sessions, and to do that, we're applying for grants, and we've noticed some of the feedback that the past members gave. The past participants gave in first and second summer school. We had some complain about their gadgets. They don't have a gadget, their internet connection, this, that. We took all those feedback, and we're also going to take your feedback. And what we are doing is we are putting all these resources together, because in this summer school, you can see 370 or I can go there and check. You can also see that over 300 or almost 400 registered for this summer school. But you see, the attendance is quite poor. Why is the attendance poor? Because of some of the challenges a lot of them are having. If you go back here and check the attendance, you can see 377 were recruited into this summer school. And out of these 377 that registered or that got into this summer school, we have, on the first day, we have, I think, about roughly 80, roughly. I've forgotten the exact figure, but it's around 80 attendees. And then the numbers keep dropping because of the challenges that they have. And we are taking note of all that. And this is part of the statistics we're going to be doing. And we are applying for grants. And part of the grants we are applying is for us to even partner with institutes or computer centers and democratize this and ensure that this gets to you. And so that even if you don't have a gadget, we have something like it could be partnerships where we ensure that you go there and you are able to practice, you are able to learn, you have an instructor there that can be able to teach you, that can answer your questions as well. We have that in mind. And also in terms of like summer school as well, where we can also enhance people's understanding in terms of like providing some of the basic things that they need to be able to stay in the summer school. We want to see how we can come up with ways to help. We can actually, when we have that, all those grants, we're applying for grants, and we've already applied for grants, we've applied for more grants. And this is also an invitation. Perhaps you want to volunteer with us. We're always welcome to receive you and to allow you to participate in that department, to bring all those beautiful ideas and put them to practice, and ensure that we make more impact. We crush all these challenges, and we move to the next step. So we are looking for that. Yes, we will make this to be a thing, to be sort of like a lifestyle in this New Life Research Foundation. We don't want it to just be a summer school and then we all go back and then we all come again next year. No, we don't want. We want to make it. We're discussing that. Our team was discussing that yesterday. We're discussing how we can try as much as possible to do that. So thank you, everyone, and God bless you. I will hand it back to Fred. A lot has been said, and I won't want to go back to all the other beautiful points. I believe you will take those points and you will keep practicing. Consistency is very important, it's very key. Discipline is very key. Staying connected is very important. Because when you stay connected, you get to know what is happening in the field. If there are other similar programs coming up, you get all the information and you're able to build your skills. Thank you very much, and I'll hand over to Fred to take over.
All right. We're going to thank you, sir. Thank you so much for that wonderful closing remark there. We're going to pray now. And I hope that whatever it is that you've gleaned from the entire program, whether you joined only today or you were here for 2 sessions, it will be profitable to you. And more importantly, we started this program introducing Jesus to you. We told you that our foundation is in Christ and that our desire is that you too will be saved. You'll come to confess Jesus as the Lord of your life. So right now, we are still going to pray, and we are praying in the name of Jesus. And we are hoping that somehow in your heart, if you are yet to give your life to Christ, you find a place to acknowledge him as Lord and Savior. Let's pray in Jesus' name. Father, thank you once again for a successful Data and AI Summit 2026. Thank you for the blessing of life, sanity. Thank you for the presence of mind. Thank you for helping us achieve a seamless, wonderful session. And thank you for everyone who has joined us and those who would watch this video afterwards. Lord, we give you all the praise in the name of Jesus. We request, oh Lord, that every knowledge that we've acquired here, everything that we have gathered will become useful to us and will give glory to your name in the name of Jesus. We cancel every distraction. We cancel everything that's going to take us away from your plan and purpose for us. Lord, every knowledge you bring our way, you bring it so that we can contribute to the advancement of your will and purpose for us here on earth. May this one not be an exception in the name of Jesus. I pray that this knowledge will become an addition to us and to your own name in the name of Jesus. We pray that you will grant us provision. We will not just learn and forget. Lord, many of us need money for data. Some of us need money to buy laptops, to buy phones, or to buy gadgets that we need to advance this learning. I pray that you provide for us in the name of Jesus. And for those who are in transit right now, who are going to various places or coming from various places, I pray for safe journey. I declare, oh Lord, that what we'll hear after now will be testimonies and testimonies in the name of Jesus. Thank you for all that you have done. In Jesus' name we pray. Amen. Thank you once again. We'll see you all next year. God bless you.